Welcome to the Spider tutorial. We will work on how to launch Spider from the Anaconda Navigator. Once inside, we'll take a look at the structure of the workspace in Spider, how we write programs, where we find our files, how we run programs, and then we'll do an example. Our first program will work from the beginning to the problem description, the pseudocode, write the statement, save it, and run it. Let's go. I have opened here the Anaconda Navigator, the suite of Anaconda programs. I basically clicked on this icon. You can also find it in your programs. Basically, it launches the possibility of all these 5, but we will only work on Spider today. Okay, this is how our Spider development environment looks. Once we get in, you notice 3 main panes. Right here, the editor. The editor is where we will write all our programs. At the beginning, we're learning to just type commands a little bit in the console. That's another pane here. Notice that we're working with the IPython console, not the Python console. And in the same pane here, there's also a history log that basically shows all the commands I have run in the past, few days, maybe a few weeks. If you need to redo something, you can always look at your history log. But here's the IPython console. It's specified that we're working with Python 3.5. Up here, there's another pane. It's called Help right now, but you can see there's actually 3 tabs. So you can have a file explorer where these are all the files, in a certain folder. This is the location I'm in right now. I can switch to week 2, and then these are the files we worked on in class. There's some assignments, some other things in here. And there's also Variable Explorer. We actually will be using the Variable Explorer quite a lot. You can change how this looks if you go up to View panes. So we have the editor, the IPython console, the Variable Explorer, Help, File Explorer, History Log. You can add other things, or you can customize with different layouts. If you want the Spider default layout, which is what we are at right now. If you want your Spider to look like your MATLAB, there's the RStudio, vertical split, horizontal split. Click on all this and see what happens. But basically the idea is that you can leave it like this. You can use some preference you have used before, for example the MATLAB layout or the RStudio layout, or you can actually create your own layout, because all of these windows, all of these panes actually are movable. So we can move the variable here, the editor here. I'm not going to go through it right now, but you can try it at home. Okay, we changed the current folder. One thing we can do, besides seeing all the files in here, we can use the list or list command, and the same thing will show up in our IPython console. This is one of the advantages of the IPython console versus just the Python console. It allows us to use different commands we usually use in a terminal window. We can use them in our Spider IDE. We're not necessarily interested in this right now, but there's just the fact that there is something extra that we can do. We would also see that any function we type, help will automatically show up in the pane help up here. If you want to clear your console, if you right click inside the console, you get a whole bunch of options. I'm on a Mac, so for me clear console is Command L. It's very possible in Windows is Control L. All of a sudden there's nothing in here, so now I can kind of start with a blank slate. Let's try to work on a project. Work on our first problem. Let's see. I've written here a text file which basically has the problem description. We want to write a program that asks the user to enter a value for the radius of a circle. The program would then compute and output or print here in the console the area of that circle. So given the radius, compute the area. And there's one other part here. Here's how a sample run might look, and we're basically going to try to match this output. So when we prompt the user for the radius, we're going to write enter the value of the radius, and when we output the value of the area, we're actually going to display both values. We're going to display the area of a circle with radius, and here will be the value that the user entered, and then here will be our calculated value for the area. Well, let's think about it first. What does it look like we need to do? Right? We need to ask the user to enter a value for the radius. And this kind of has, let's say, two parts. 1A would be prompt the user to enter a value. And we have strict message here. We have to use exactly this thing in order for our output to match exactly. So we're going to use, we're just going to copy this from here. We're going to use the colon and the space so that everything looks exactly the same. And then once the user enters a value, we're going to save the value entered by the user in variable named, let's say, just R. Okay, that's the first part. Then we want to compute the area of the circle with radius R. So the area of a circle is pi r squared, so our formula would be pi times r squared, r to the power of 2. We'll see how that translates into a Python command, but just as an aside, we're going to use the value of pi 3.14. So when we actually write our statement, our expression, we're just going to replace pi with 3.14, and we're going to save this in a variable named area, right? And then part 3 would be display output print message that contains basically the text above and the appropriate values for radius and area. Okay, now let's kind of start in here. So for the first part, we want to ask the user enter the value of the radius, and because we want to save that value, we're going to use the input function. So we're going to say r equals input, and as the moment I opened input and I rounded the parentheses, the IPython console brought up here in the help menu how the input function works. So give it a prompt string, and our prompt string is in quotes, and we're going to say enter the value of the radius. We're going to close the string, close the parentheses for the input function, and with this we're done. Let's say we enter the value of the radius to be 5, and once we do this, the prompt shows up again, but another thing that happens, now we have a variable r in the variable explorer. Its value is 5, but it's not exactly 5 because it is a string. So it's basically a string 5. So if we just type in the console r or print r, we would get 5, right? So this is the value, this is the fact that it's actually a string. So now if we come to the second part and we want to compute the area, we want to do r to the second power, but we cannot really do a string to the second power. So we need to convert r into a floating point value or an integer value. In this case, 5 is an integer, but just in case the user would have entered something like 5.2, 5.3, 10.7, let's just convert to a floating point. So then r would be float r. So whatever the value of r was as a string will now be converted into a numerical value, a floating point value. Okay, and we can print it now, and it shows as 5.0, and we can also see in the variable explorer that the type has changed. It's now a float, which means we can use it in any sort of arithmetic expressions. Now let's figure out how we write this arithmetic expression. So we have a variable named area, and we're gonna assign it the value of, this is the assignment operator. The expression comes on the right hand side of the assignment operator, and we need to do pi times r squared. So for pi, we said we're going to put 3.14. We're going to put the multiplication sign, and then for r squared, we have r to the second power. This is r to the second power. This is the exponentiation operator. If you're not quite sure how the order operation works first, if you're somehow afraid, then maybe 3.14 will get multiplied with r first and then everything raised to the second power, you're free to use parentheses. But please refer to the book. Maybe, just maybe, you'll find out that in this case you didn't need parentheses. So now we have area. Area shows up here. Here is the value that was calculated. It seems to match our sample run. And the only thing we have left to do is to print the message with the text and the appropriate values. So we're just going to say print, open up the print function. We can add multiple values separated by commas. So first, we are going to add the text from here, the area of the circle with radius. Then we have the value of the radius. So we're just going to put the variable r in there. The print statement will generate here the value 5 or 5.0 basically. And then we have the next part of the text here is, and then let me move this just a tiny bit, and then the value of area, and then we close the parentheses here, notice, and then we're going to print it. The area of a circle with radius 5 is 78.5. So everything is pretty good, but what if we want to run the same code and compute the area of a circle with a different radius? So we can clear out the console again, and let's see. If I use the up arrow on my keyboard, I can print up, bring up previous commands. So we can do input radius again. Maybe this time we're going to say, I don't know, 6.7. And then the next thing we did that was important is to typecast this structure into a float. Then the next thing we did was calculate the area. Then the next thing we did, the last thing we did, is actually print out the message. So we have 4 statements that would make up our program, but every time we want to calculate a new area value for a new radius, we have to go through these 4 statements again. So this brings us to how can we do this to make our jobs easier? Not to mention that if we turn off, if we close Spider, all of this will go away, so we would have to kind of type it all again. So that's where we write our first program. So we can go in here, new file. It shows up as a Python file, .py. Right now it is untitled, but we're going to give it a title. It has some information here about when it was created. You can change this to add your own name, to add maybe like a header. This is my name, this is my student ID, where you can always have the same thing for every file you create. And then we can put maybe the problem description. Let's see if we can put the problem description here into a block comment statement. Okay, so this is the problem description. Okay, then we can even go further and put in here the algorithm. I'm copying from the text file where I was, right? So prompt the user for a value. Okay, and then this comment corresponds to this statement. So we can write our statement here. And we forgot to put an extra space in here, but everything is fine. Okay, then the second part was making sure that we save the value entered into the variable named R as a floating point value, right? So that's this part here where we typecast the string as a float. Okay, the next part of our algorithm was to compute the area of the circle. Notice I'm making all these comments, but they're very useful to what I'm doing. Every part of the algorithm basically translates into one or more statements. Here we broke it into two basically. Then the last part was print the message, and this is what we're doing right now. And this is the last part here. So now this is our program. This is it, but we gotta save it. So we're gonna save file, save as. That's my current folder, which matches the thing here. We're just gonna call it, let's say, area circle.py, right? Once we have it saved, we said that very important is that we don't type it all the time. So let's clear the console again. Control R, Command L, and let's see how do we run a script. So there's multiple ways. There's a button here that just says run file, or also F5. So you can press F5 or you can click on run file, and it says run file. Here is the path to the file, here's the directory, and then all of a sudden the things I did here already show up. I don't have to type anything anymore. Here's 5, and this is the output statement. None of the other statements that did the typecasting and the computation showed up here. They will all run, but this is just what the user sees. And notice that it matches exactly what we wanted to have for the sample run. That's a sample run. Imagine what the user would see. Okay, so one way of doing it is doing the green triangle, the green play button, run file. F5 is another one. Another way is to get into your File Explorer, and now we have here area circle. That's the one we just wrote. We can do a right click on it and press run. This will actually open a new console just for the running of this program, which is actually recommended. It makes a lot of sense. We can do the same thing. Here we go, and then the prompt shows up again. So running it from here, running it from here. You can also go up at the menu, the run menu, and click run, which is also F5. There we go. The same thing shows up again. This concludes our tutorial. We'll do more examples soon. Have a good weekend.